Hello students, welcome to Anand Academy of Education. This is our first lecture on sequences and series, and in this lecture we are going to see the basic introduction to sequence and series, the definitions of sequences, series and progressions. Uh, and students, I will teach this lecture in a way that you can be able to crack Eamcet, JEE, Bitsat or any other state engineering entrance exam. So I request you to listen to this lecture with a pen and paper in your hands. So without much further delay, let us go to the lecture. So what is a sequence? The first and foremost step in any chapter is to know the basics and definitions. So here also we'll start with the basic definitions. So the first basic definition. What is a sequence? What is a sequence? Sequence is nothing but arrangement of numbers in a certain order. Arrangement of numbers in a certain order. Certain order. What does certain order mean? Certain order means that arrangement of numbers following a specific law. Following a specific law. Let us take an example to make you understand better. So let us take 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So if you could observe, except the first term, each term, next all the terms except the first term, this is first term, we call this T1, this T2, T3, T4, T5 and so on. We have terms up to T10. So if you could observe, T2 is formed by adding 1 to first term, its prior term. Similarly, T3 is formed by adding 1 to second term, and similarly fourth term is formed by adding 1 to third term. Likewise, all the terms here are formed by adding 1 to their prior terms. So what is the law here? The law is adding 1 to its prior term. So Tn, how is Tn formed? Tn is formed by adding Tn minus 1 plus 1, isn't it? So Tn is equal to Tn minus 1 plus 1. So what is T2? T2 is T2 minus 1 plus 1, that is equal to T1 plus 1. What is T1? T1 is 1. So 1 plus 1, 2. So each term in this collection of numbers has followed a specific law, or otherwise they're all formed by a specific order. They are not formed in a random way. Each term in the sequence has followed a specific order. Let us take another example. 1, 6, 36 and 216 and so on. Is this a sequence? Yes, this is a sequence because second term is formed by multiplying 1 with 6. Similarly, third term is formed by multiplying second term with 6. Similarly, fourth term is formed by multiplying third term with 6. Here also we can observe a specific order. So we can say that this collection of numbers is a sequence. This collection of numbers is a sequence. So what would not be a sequence? Numbers arranged in a uncertain order, meaning there is no specific order for such numbers. If numbers are not arranged in a specific order, then it would not be a sequence. Then it would not be a sequence. It is as simple as that. Sequence is a very basic, very easiest thing. So what is a sequence? Sequence is nothing but arrangement of numbers in a certain order. And now let us look at the types of sequence. We basically have two types of sequences, finite and infinite. So what does finite sequence mean? Finite sequence, as the name itself says, finite sequence is countable, or it is restricted to a countable number of numbers. For example, 1, 2, 3, 4, 5. This is a finite sequence. This is a finite sequence because the terms here are finite in number. So this is a finite sequence. Similarly, 1, 6, 36, 2, 16. 216. This is also a finite sequence. And what is infinite sequence? Infinite sequence is a sequence that involves infinite number of numbers. For example, 1, 2, 3, 4, 5, and so on. So there is no end to this sequence. There is no end to this sequence. So we call this sequence as infinite. So we call this sequence as infinite. So finite sequence is countable. The number of terms can be countable, whereas in infinite sequence the number of terms are countless, and therefore we cannot count the number of terms in infinite sequence. And now, what is a series? What is a series? We have just learnt what a sequence means, and now what does a series mean? A series is as simple as a sequence, and the major difference between sequence and series is sequence and series. Major difference is order of elements is not important in a series. In a series, order of elements is not important. Also, a series is defined as the sum of elements of a sequence. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So if this is a sequence, and then its series is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So this is a sequence and this is a series. So series is nothing but the sum of elements of a sequence, and we denote this sum of this elements as Sn. Here n is 10, so this can be written as S10, sum of 10 terms, because here we have 10 terms. So sequence is arrangement of numbers in a certain order, and series is a sum of those elements arranged in a certain order. So now let us look at the nth term in a series. Nth term, so Sn, for suppose we have a series 1 plus 5 plus 9 plus 13 plus 17 plus and so on. So this is T1, this is T2, this is T3, this is T4. Let us make this series finite. T10. For suppose we have 10 terms, then if the sum of 10 terms is Sn, or for suppose S10, this is S10. Sum of 10 terms is this 1 plus 5 plus 9 plus 13 and so on plus T10. So the sum of first term to sum from first term to 10th term. So now Sn is 1 plus 5 plus 9 plus and so on. It would be up to T9, T1 to T9, T1 plus T2 plus and so on plus T9. So what is S10? S10 is sum up to 10 terms. S10 is sum up to 10 terms and S9 is sum up to 9 terms. So if we subtract S9 from S10, what would we get? T1 plus T2 plus and so on plus T10 minus T1 plus T2 plus and so on plus T9. So what would we get? T10. We get T10. So to find the nth term in a series, given the sum of numbers of that series, so Sn minus Sn minus 1 would give us nth term. Would give us nth term in a series. Would give us nth term in a series. So I think you now have understood how to find the nth term in a series. Just like how we have finite and infinite sequences, we have in finite and infinite series. Finite and infinite series. So what is finite series? A finite series is a series that involves finite number of terms in its series. So finite series involves finite number of terms. We have just seen an example. So that was a finite series. S10 T1 plus T10. We just have 10 terms. So this is countable. This is finite, and so this is a finite series. Infinite series is uncountable. We have infinite number of terms, and so this is infinite series. And now let us look at progression. What is a progression? Now that we have seen what a sequence mean and what a series mean, now let us know the definition of a progression. A progression is a series of numbers arranged in a logical pattern. A series of numbers arranged in a logical pattern. For example, let's take this progression 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. If you could observe all the terms in this series, all the terms in this arrangement have a specific pattern. For example, the difference between first term and second term is 1. The difference between second term and third term is 1. Difference between third and fourth term is 1. Similarly, the difference between every term and its next term is 1. So all these terms in this series follow a specific pattern. So we call such series which follow a specific pattern as a progression. And we have basically 3 types of progressions which we will be dealing in this particular chapter, sequence and series also. Arithmetic progression, geometric progression, and third, harmonic progression. So in this chapter, we'll be dealing with these three progressions, although we have different kinds of progressions. We only have three kinds of progressions for our syllabus: arithmetic progressions, geometric progression, and harmonic progression. And we will learn these progressions from our next video lectures. For now, this is it for this lecture. So let us have a quick rewind. So we started with the definition of sequence. A sequence is nothing but an arrangement of numbers in a certain order. And there are two kinds of sequences: finite and infinite. Finite sequence is a sequence that involves finite number of terms, and similarly infinite sequence involves infinite number of terms. Similarly, a series is nothing but sum of elements of a sequence. And a progression is a series of numbers arranged in a logical pattern. And we have types of progressions: arithmetic progression, geometric progression, and harmonic progression. And we'll look into these progressions from our next video lectures.